The universe isn't just big, it's ridiculously precise. Every galaxy, every planet, every star exists because of one mind-blowing event. But what if I told you the universe needed a cosmic hack just to make sense? And what if that hack is the reason you're sitting here today? Let's talk about inflation, the universe's greatest plot twist. Alright, so we all know the Big Bang was the ultimate kickoff event, the cosmic fireworks show that got everything rolling. It started with an unfathomably hot and dense singularity, then expanded, cooled, and eventually gave us galaxies, stars, and planets. But here's the problem. Without a little something extra, the universe as we see it today shouldn't even make sense. For starters, there's the horizon problem. Why does the cosmic microwave background, also known as the universe's baby picture, look almost too uniform? Distant regions of the universe are chilling at the same temperature, but given the expansion rate, they should have never had time to talk, trade heat, or even send a friendly wave. Yet somehow, the universe acts like it was in perfect thermal sync from the beginning. Then there's the flatness problem. Precise measurements show the universe is suspiciously close to being perfectly flat. The odds of this happening naturally are like randomly balancing a pencil on its tip. Possible, but highly unlikely. Without an explanation, this level of fine-tuning is just plain weird. And let's not forget the Monopole Problem. Grand unified theories predict that the early universe should have produced loads of these hypothetical supermassive magnetic monopoles. But despite our best efforts, we've never found a single one. If they were as common as expected, they should have been all over the place, throwing off the balance of everything we know. Enter cosmic inflation, a brilliant idea from the late 20th century that suggests the universe expanded at an absolutely bonkers rate just fractions of a second after the Big Bang. We're talking exponential growth, from subatomic to cosmic in less time than it takes to blink. This rapid stretching explains why everything looks so uniform. Before inflation, the universe was small enough for all regions to interact and reach thermal equilibrium. When inflation hit, it blew everything apart so fast that those conditions got locked in, giving us the smooth, even-tempered cosmos we see today. It also solves the flatness issue. Just like blowing up a balloon makes its surface appear flatter, inflation stretched out any initial curvature, making the universe look practically Euclidean. So instead of some weirdly warped or crumpled universe, we got one that behaves in a mathematically simple way. And those pesky monopoles? Inflation diluted them into oblivion. If they were running around in the early universe, the rapid expansion would have spread them so thin that they'd be virtually undetectable now, which is why we don't bump into them on our morning walks. But what actually caused inflation, and why did it stop? The answer likely lies in a hypothetical field known as the Inflaton Field. Unlike familiar forces like gravity or electromagnetism, this field wasn't messing around with particles, it was controlling space itself. During the Inflationary Period, the Inflaton Field was stuck in a high-energy state, preventing the universe from expanding at a normal rate. Once it finally decayed into a lower energy state, it released an enormous amount of energy, reheating the universe and allowing matter and radiation to form. This transition marked the end of inflation and the beginning of the universe as we typically describe it. Basically, inflation was the universe's dramatic growth spurt, and the Inflaton field was the hormone behind it. Now here's where it gets really wild. Quantum fluctuations at microscopic scales got stretched out during inflation, meaning tiny random wiggles in energy became the seeds for galaxies, stars, and cosmic structures. Picture a completely empty sandbox. Inflation comes along, stretches out tiny ripples in the sand, and over time, those ripples grow into massive dunes. Without inflation, the universe would be a featureless void. With it, we get the grand cosmic web, the intricate network of galaxies and voids that make up the large-scale structure of the universe. And the proof? Those faint irregularities in the cosmic microwave background, the very fingerprints of these early quantum perturbations, match exactly what inflation predicted. They later grew under the influence of gravity, leading to the formation of everything we see in space today. Speaking of evidence, one of the strongest confirmations of inflation comes from the detailed observations of the CMB. The tiny temperature variations in this relic radiation match the patterns predicted by inflationary theory with eerie accuracy. And it's not just the CMB. Large-scale galaxy distributions also align perfectly with the expected growth of quantum fluctuations during inflation. But scientists aren't stopping there. They're on the hunt for primordial gravitational waves, ripples in space-time that should have been generated during inflation. If detected, these would serve as direct proof that inflation actually happened, elevating it from a highly successful theory to a verified cosmic fact. Of course, not everyone is 100% sold on inflation. While it's the best explanation we have, some questions remain unanswered. For one, what exactly is the Inflaton particle? We know the field must have existed, but no one knows what particle, or combination of particles, was responsible for driving inflation. And then there are alternative theories. Some models, like the Echorotic universe, propose a cyclic cosmic evolution, meaning the universe didn't start with a bang but has been expanding and contracting forever. Others tweak inflation itself, trying to explain the same observations in different ways. But so far, no competing theory has provided a more compelling or comprehensive explanation than inflation. And now, for the ultimate mindbender, some versions of inflation suggest that it never really stopped. Instead, different regions of space continue inflating indefinitely, leading to an eternally inflating multiverse, where new bubble universes are constantly being born. If true, that would mean our universe is just one of countless others, each with its own unique physics, constants, and possibly even laws of reality. Think about it. Somewhere out there, there could be a universe where gravity repels instead of attracts, or one where time runs backward, or one where you actually text people back on time. Today, inflation stands as one of the most successful and widely accepted theories in cosmology. While questions remain, its ability to explain otherwise mysterious features of the universe, its homogeneity, flatness, and structure, makes it an indispensable part of modern scientific thought. And with new telescopes and experiments in the works, the coming decades may bring even deeper insights into the first moments of existence. Who knows? We might even discover something that changes our entire understanding of space, time, and the cosmos itself. I'll leave you to discuss in the comments. What do you think about the possibility of a multiverse? You can support us by subscribing if you haven't already. Take care of yourselves, take care of your loved ones, and I'll catch you soon in another video.